Okay, so the first step to solve this problem is using Newton's law of cooling to determine the time of death of Mr. Phi. So we're given these variables, given that at 6 p.m. the body's at 80 degrees, at 7 p.m. it cools down to 75 degrees, and the ambient temperature of the room is at 70 degrees. What is going to be the time of death for Mr. Phi at this homicide? So we're going to plug in our variables into this equation. So 75 equals 70 plus 80 minus 70 times e to the negative k, and I'm using 60 as my time for 60 minutes elapsed between 6 and 7, but you can also use 1. I just think it'll be easier to use 60 to use the variable for minutes. Then you're going to simplify this down to 5 equals 10 e to the negative k times 60, and then divide 5 by 10, which is going to give you 1/2, equals e to the negative k times 60. And once you do this, you need to isolate k by removing e using natural log. So we're going to take the natural log of 1/2 equals the natural log of e to the k times 60. So for the natural log of e, that's just 1. So you're just going to move the exponent down to the coefficient so it all cancels out, and you're just going to get negative k times 60. So natural log of 1/2 equals negative k times 60. After you've done this, you're just going to enter this into your calculator and divide the natural log of 1/2 by 60 to isolate k, and you're going to get k equals 0.0116 approximately. So given k, which is our decay coefficient, you're going to create a new formula to find t, the time elapsed from the time of the homicide to when the body was 80 degrees, which you can also do whenever the time was 75, but this is closest to the time of the homicide, so I'm going to use that. So 80 equals 70 plus 98.6, which is the average temperature of a human body, minus 70 times e to the negative because that is how you determine k. It's always negative because it's the decaying, 0.0116 times t, which is what we're trying to find. Simplify this down to 10 equals 28.6 e to the negative 0.0116 times t. From here, you're going to take the natural log of both sides of the equation. So we're going to divide 10 by 28.6. So it's going to be the natural log of 10 divided by 28.6 equals, so on this side we have e, and just like in this other equation, it's going to cancel out to just give you 1. So it's going to be equal to negative 0.0116 times t. And all you do is enter this into your calculator, divide by negative 0.0116 to give you t. So once you enter this into your calculator, you're going to get negative 1.0508 approximately equals negative 0.0116 times t. Divide this by negative 0.0116 to give you a t equals 90.59 approximately. So this is going to be the time elapsed from the time of death to the discovery of the body at 6 p.m. So you have to remember that I did this in minutes, so it's 90.59 minutes. So we're going to round this to 91 because that makes a little more sense. So T equals 91 minutes. So if we subtract this from 6 p.m., an hour before would be 60 minutes. So at 5 p.m., there's still have to subtract 31 minutes. I just think this is the easier way to do it. So it's going to be 4:29 p.m. is the time of death of Mr. Fies. And that is how you use Newton's law of cooling to find the time of death of Mr. Fies. Thank you.